Assalamu alaikum. For past paper questions for more complex equations, we will be starting the questions now. And the first question that has been chosen, it's a simple question, but for the recap of the past concept, let's do the question here. It says that the function f is such that fx is equals to 8 minus x minus 2 the whole square, and x belongs to all real numbers. Find the coordinates and the nature of the stationary point. Coordinates, we need the coordinates as well as the nature of the stationary point on the curve y equals f of x. So to solve this part, we know that the function fx has been given as f of x, which is equals to 8 minus x minus 2 the whole square, and it's such that for x belonging to all real numbers. So I can see that if I just rearrange, it's the coefficient that is outside the quadratic is a -1. Therefore, for all negative quadratic functions, we know that the nature needs to be a maximum. And also, as this function has been expressed as completed squared form, we know that the turning point has to be for 2 and 8 here. With respect to the negative that we have here, we know that the nature has to be a maximum nature. So the nature is going to be a maximum in this case. So we can say that the nature is a maximum, and the coordinates at which the turning point occurs or the stationary point occurs needs to be a 2, 8 here. So this is how this equation is going to get formed. Second part of the question says it's the same function which is g. Second part, it says it's the same function which is gx, and this is 8 minus x minus 2 the whole square, but now the domain is different. They are saying now it is for k to be lesser or equal to x, which is lesser or equal to 4. So I know that if the curve has a maximum nature, and now it's getting defined for k lesser or equal to x lesser or equal to 4, then this means it's 2 and 8. Let's say 2 and 8 was of maximum nature at this point. So it has to be up till the value which is a 4. And to define it for k lesser or equal to x lesser or equal to 4, we need the smallest value of k here, for which g has an inverse. The inverse exists. So we know for the inverse to exist, we should be breaking it at the turning point, meaning I can say that this domain needs to be from 2 till 4 so that the g inverse can be defined. So in this case, for k to be lesser or equal to x lesser or equal to 4, I should know that my domain should be from 2 lesser or equal to x lesser or equal to 4. Therefore, the k value needs to be, the smallest k value needs to be a 2 in this case. So we have the value of k. Now find an expression for g inverse also. Now once we have the domain value, which is for x is equals to 2, we know that the function value or the y value is an 8. In the same manner, we can get the value for the function when g of x is a 4, and I can see here that this becomes 8 minus 4 minus 2 the whole square, so that this is 8 minus 2 the whole square, or I can say that this value becomes 8 minus 4, which gives me a 4 here. Meaning when x is a 4, my y coordinate needs to be a 4 also. My y coordinate here needs to be a 4 also. That means this is how my graph shall be. So when x is a 4, I know that the function value or the y value also comes out to be a 4. Therefore, I can also give the range of the function, and I can see that the range is getting defined from 4 till 8. This is the range value from 4 till 8, so that I can also say that the range of the function shall be from 4 lesser or equal to g of x, which is lesser or equal to 8 here. So after getting this value, they are saying find an expression for g inverse x. So to find an expression for g inverse x, my g of x is equal to 8 minus x minus 2 the whole square. Substituting with y, this becomes 8 minus x minus 2 the whole square, and I can say that it's x minus 2 the whole square. Bringing it to the left, it becomes positive, and this becomes 8 minus y. Taking the square root on both the sides, this becomes x minus 2, which is equals to plus minus under root 8 minus y, or I can say x is equals to 2 plus minus under root 8 minus y here. So for this g inverse, I know that it's a 2 plus minus under root 8 minus x. So I have the equation. Now I just need to define it for the plus or the negative sign. So what I know is that for g inverse here, my domain has to be from 4. For the inverse function, we know that the range and the domain, they get flipped. Therefore, the domain of the function, the inverse function, the domain for g inverse shall be from 4 lesser or equal to x, which is lesser or equal to 8, and the range of the function, the range of g inverse, has to be from 2 lesser or equal to g inverse x, which is lesser or equal to 4. So from here I can see that the domain value is getting increased, the function value is also getting increased, the range value, it's also getting increased from 2 to 4. Therefore, simply I can say that my g inverse is an increasing function with the sign which is going to be a positive here. So this becomes 2 plus 8 minus x. This is going to be my inverse function. So that's why it's important to have the domain and the range, so that we can also define the signs of the g inverse function here. So we have the inverse function. Now the last part of the question, it says sketch on the diagram the graphs of y equals gx and g inverse. So just to sketch the diagram, so for gx, it was from 2 lesser or equal to x, which is lesser or equal to 4, and my range was gx lesser or equal to 8. And therefore, for the g inverse function, I know that the values just need to get flipped. Therefore, it should be for the domain 4 lesser or equal to x lesser or equal to 8, and the range, which is 2 lesser or equal to g inverse x, which is lesser or equal to 4 here. So to sketch the function, what I know for the function is that for the graph, when my x is a 2, my y value is an 8. When my x is a 4, my y value is also a 4. That means this point, which is 4 and 4, it should be lying on the line which is y is equals to x. So 2, 8 and 4, 4 just sketched on this diagram shall give me 2, 8. I should be having 2, 8 somewhere here, and 4, 4. It should be having me this kind of curve, which is representing 2, 2 and 4 and 4. So this means if I need to have the inverse function, then 2, 8 and 4, 4. 2, 8 and 4, 4 sketched on the diagram. To get the inverse function, 4, 4 lying on the line which is y equals x will remain invariant. 2, 8 will get flipped, and this is how it shall be the two functions. It should be my gx here, and this is going to be the inverse function, which is g inverse x. So this is how we are going to do this question now. The next question is chosen from Summer 22, Paper 1, Variant 1, and this is question number 6. Now, this question says that your fx is a reciprocal function. It is x square minus 4 over x square plus 4, and it is defined for the domain values x greater than 2. So we need to find the inverse function here. So to get the inverse function, let's equate it to y so that this becomes x square minus 4 divided by x square plus 4. I know that I have to make x the subject, therefore y gets multiplied with x square plus 4, which will give me x square minus 4, and then this becomes x square y plus 4y, which is equals to x square minus 4. Bring all the x's on one side so that this becomes x square y minus x square, and this becomes a negative 4 and a negative 4y. In other words, I can also say, to flip the sign, I can say that this is x square common y minus 1, and this is a negative 4 common and 1 minus 1 plus y left here. To solve for the negative sign, if I just take it to the left side, I know the signs of the term will change, and so this becomes x square bracket 1 minus y, which is equals to 4 bracket 1 plus y, or I can say x square is equals to 4 1 plus y divided by 1 minus y here. And to get the square root of the function, what I should know is that my function value has to be x, which is equals to plus minus 4 1 plus y divided by 1 minus y with the sign of under root here. So x is, the domain says it has to be for the x values which are greater than 2. So all the x values, they need to be greater than 2. It's a reciprocal function. So I know that for this reciprocal function, my graph needs to be asymptotic towards the x-axis and the y-axis. So if x is greater than 2, then my function values needs to be all positive also to be greater than 0. Therefore, to be greater than 0, I should say that the function inverse shall be the function inverse here, f inverse x shall be with the positive sign, and I can say that this is a 4 1 plus x divided by 1 minus x here. So this is how my inverse function is going to be. So the second part of the question, it says show that 1 minus 8 over x square plus 4 can be expressed as x square minus 4 divided by x square plus 4. So for 1, we have to show that it's 1 minus 8 over x square plus 4. So if I just take the LCM, or if I just so to solve it, I should multiply 1 with x square plus 4, divide also by x square plus 4, so that the denominator becomes the same for both the terms. So that simply I can say it's x square plus 4 minus 8 divided by x square plus 4. And this then can be written as x square minus 4 divided by x square plus 4. And then this is shown here. So what I have seen here is that my function fx can also be written as 1 minus 8 divided by x square plus 4, which is also equal to x square minus 4 divided by x square plus 4 here. Now, hence state the range of f. So for the range of f, I know that the given domain for the function, in the first part, they said that this function is defined for x to be greater than 2. So for x to be greater than 2, what I know is if I substitute f as a 2, my function becomes 1 minus 8 divided by 2 the whole square and a plus 4. So this then becomes 1 minus 8 divided by 4 plus 4, and I can see here that f of 2 is giving me the value which is equals to 0. Meaning when my x is a 2, the function is becoming a 0. That means this basically is the x-intercept here. So if this is the x-intercept, this basically is my x-intercept. Two comma 0. So the constant in the equation where we said that f of x is equals to 1 minus 8 divided by x squared plus 4 is of great importance, because what we know is that this constant in the equation, this constant which is 1 in the equation, is always representing the y asymptotic line if the function is a reciprocal function. That means if I just substitute, if I say that my function value equals a 1, let's say that my function value equals a 1, what happens is I will be having 1 which equals 1 minus 8 divided by x squared plus 4, or I can say that this is going to be 8 over x squared plus 4 giving me 1 minus 1 which is equals to 0, meaning this is this particular value where your function is becoming asymptotic, it's becoming undefined. If I just cross multiply this x squared plus 4 with a 0, it just vanishes, it becomes undefined here. So whenever in the function equation there is a constant, so this constant will always be representing the asymptotic line, meaning I should be having this value as a 1. I know that my x needs to be greater than 2, function value x needs to be greater than 2, and when I substituted my x as a 2, I was getting the y value as a 0. And so this means that being asymptotic towards the line y equals 1, I should be having the curve which shall be going this way, being asymptotic towards the line y equals 1 here. So the range of the function then becomes 0 lesser or equal to f of x, which is lesser or equal to 1 here. So this is going to be the range of the function with respect to the reciprocal function having a constant also which is a 1. So this is why in the question only they have given us the form of 1 minus 8 divided by x squared plus 4, so that very easily we can just get the actual values for the domain given as x greater than 2 and the asymptotic line which is a 1 there. So let's do the third part. Last part of the question says explain why the composite function ff cannot be formed. Cannot be formed. So for the composite function cannot be formed, we know that a function can be formed only if the range of f, the first function, range of f should be less than the domain of f, which is the second function in this case, and both of them, they are the same. So f of f, that means the range that we just obtained was from 0, the range was 0 lesser or equal to f of x, which is lesser or equal to 1, and the domain said it needs to be greater than 1. So I can very clearly see that the range here is not lesser or equal to, the range here is not lesser or equal to the domain. Therefore, I should know that the range does not lie, as the range does not lie within the domain. Therefore, the composite function ff cannot be formed here. So this is how. So the next question is taken from May June year 22, and it's variant 2 and question number 10. So f of x is given as a 2x plus 1 divided by 2x minus 1. क्या कर रही हो आयशा? तो शोर क्यों बहन? So function f is given as 2x plus 1 divided by 2x minus 1, and we know that this function should not be equal to 1 by 2, because if I substitute x as 1 by 2, I know that my denominator becomes a 0, and if my denominator here becomes a 0, then the function becomes undefined, and a function cannot be undefined according to the definition of functions. Therefore, this is already given that should not be equal to 2. Now state the domain of f inverse. So what I see here is that for the domain of f inverse, what I see here is that x equals 1 by 2 is actually the asymptotic line. Let's make the asymptotic line here. X equals 1 by 2 is actually the asymptotic line. This is my asymptotic line, which is x equals a 1 by 2. So here the function is becoming asymptotic, and for the function what I can see is that this function is actually becoming asymptotic also towards the line which is y equals 1. So if they are asking us for the domain of f inverse, so for the domain of f inverse, I know that the domain is actually from 1 up till positive infinity and from 1 up till negative infinity here. I can see that my range is from 1 up till positive infinity and from 1 going towards negative infinity also. So if they are asking us for the range, for the domain of the inverse function, then for the domain of the inverse function, we know that the values, they get flipped, and here it's becoming asymptotic towards the line x equals 1. Therefore, for the inverse function, for f inverse, I'm just flipping the domain. Let's write the for the domain, so let's write the domain of the function first. So the domain of the function is actually for fx, the domain for fx is actually x should not be equal to 1 by 2, but I can see that it is for x to be greater than 1 by 2 or x to be less than 1 by 2. And if I look at the range of the function, then the range is for x, for y, or the function. And for the range of the function, it's very much clear from the graph that it's becoming asymptotic towards the line y equals 1. So I should say that for the range of the function, f of x should not be equal to 1, and we should say that it's f of x to be greater than 1 or f of x to be less than 1 also. So if they are asking us for the inverse function and they are asking us for the domain of the inverse function, then we know that the range and the domain, they get flipped. Therefore, the domain of the inverse function shall be x should not be equal to 1 and x is greater than 1 or x to be less than 1 here. So this is going to be the answer for this question. So find an expression for f inverse. So to find the expression for f inverse, it's just that I need to equate the function to y, and then I just need to simplify for x so that I can say that it's 2x minus 1 getting multiplied with y. That would give me 2x plus 1. I have to make x the subject. So I will be bringing all the x's on one side, so that this becomes 2xy minus 2x, which is equals to 1 plus y here. So taking x common, I will be left with 2y minus 2 with x as common. So this becomes 1 plus y, or I can very easily say that x is equals to 1 plus y divided by 2y minus 2, or my f inverse becomes 1 plus x divided by 2x minus 2, and for this function I should know that x should not be equal to a 1 here. So x should not be equal to a 1. This is what we have previously shown in the question, where we said that the range of the, for the range of the function f of x was not equal to 1. So it's very much obvious for the inverse also, that now the domain says it's x which should not be equal to a 1 here. So this is what is going to be the expression for f inverse. This part C of the question says find g f inverse of 3. So first we need to find the composite function g inverse. So to have the composite function which is g inverse, I know that in the function g I should be substituting f inverse, so that this becomes 1 plus x divided by 2x minus 2 the whole square, and then it's a plus 4. So this is going to be the function, the composite function g f inverse. Question says find it for x value as a 3. So g f inverse of 3, I'm just going to substitute my x with a 3, so that this becomes 2 times 3 and a minus 2, and it's a square, and then it's a plus 4. So this is a 4 divided by 2 3s are 6, and 6 minus 2, that would also give me a 4 the whole square and a plus 4. That means this becomes simplified, and 1 square is a 1 plus 4, and I know here that g f inverse of 3 shall be equal to a 5. So this is going to be the answer for this part here. It's a very simple part, very simple working to do for this part. Explain why g inverse cannot be found. So we know that g of x has been given as x squared plus 4, and it says that x belongs to all real numbers. So what I know here is that it's basically the quadratic graph with a minimum turning point, and the y-intercept is a 4. That means the y-intercept is actually the turning point here, and this is how my graph is going to be for gx equals x squared plus 4. So what I know is that this function is a many to one function. This function, it's a many to one function, and for many to one function, if I get the inverse, we know that for all many to one functions, without getting it limited from the turning point coordinates or breaking it at the turning point, the function becomes one to many. So if the function becomes one to many for the inverse, one to many is the inverse function, is the g inverse function. Therefore, g inverse cannot be formed. That is because the domain has been given for all real values of x. If they would have just broken it, limited it at the turning point or either side of the turning point, then we could have found the g inverse. But at the moment, considering all the real values, the inverse cannot be found, because for this condition, the inverse function becomes one to many here. So that means this is how the inverse function shall be. So with this inverse function, with the x coordinate as x-intercept as a 4, it becomes a one-to-many function, and therefore for one-to-many functions we say that g inverse then shall not be possible. So this is the reason for this question here. So the next question has been taken from Winter 21, year 21, 2021, and it's variant 3, and it says the diagram shows the graph of the function. The diagram shows the graph of the function, and on this diagram we have to sketch the graph of y equals f inverse. We have to sketch the graph for f inverse. So if we have to sketch the graph of f inverse, then obviously the first thing is to have the line which is y equals x. So if I just look at the graph, and if I say that this is my first function which needs to get reflected, then I know that after reflection this shall become a function which goes this way. And for the function which is in the second quadrant here, if this gets reflected along the line y equals x, then I know that this shall be going. What I come to see here is that the blue line for the inverse for the function itself, that this curve shall be reflected along the line y equals x, giving me this line. And for this part of the curve, which was my function, I should say that this after reflection becomes, so I have divided, so to sketch the functions, I have divided it into two parts. This is the first part, and this is the blue line, the blue curve is the first part, and the purple curve is the second part. So for the first part, I have reflected the curve here so that I'm obtaining this blue curve here. And for the second part, I have reflected this part of the function so that I'm getting the purple curve here. So now I know that for my inverse function, the value, the graph should be the curve which goes like this. So this is going to be my G inverse, my F inverse function here. This shall be my F inverse function here. So the trick is divide it into two quadrants and then reflect each of the quadrant curve along the line y equals x. So now for the same question, they are saying it's now given that f of x. So initially, they just said that it's the curve which is which is y equals fx. We got the inverse of the function, sketch of the inverse function. And now it says that it's given that f of x equals negative x divided by under root 4 minus x squared. For minus 2 lesser, now they have limited the function. The domain is for negative 2 till positive 2. So find an expression for f inverse x. We know that the domain has been defined now from negative 2 till positive 2, and we need to have an expression for f inverse. So simply we will say that f of x is equal to negative x divided by under root 4 minus x squared, and this is for the domain negative 2 less than x, which is less than 2. So y times 4 minus x squared to the power half shall be equal to minus x here. So y times 4 minus x squared, the whole to the power 1 by 2, shall be equal to negative x. So if I take square root on both the sides, if I take the square on both the sides to eliminate the square, then what I know is that the function becomes y square bracket 4 minus x square, and this also becomes an x square value. So solving it further, it's 4y square minus x square y square, which is equals to x square, or 4y square is equals to x square plus x square y square, or it's 4y square, which is equals to x square common, and I'll be left with 1 plus y square, or it's a 4y square, which is equals to x square, and this is getting divided by 1 plus y square. So my x square shall be 4y square divided by 1 plus y square, or I can say that my x value is a 2y divided by under root 1 plus y square here. So obviously with the positive and the negative sign. So with the positive and the negative sign, so now I need to decide between the positive and the negative signs, and I know that this is basically the inverse function, which is a plus minus 2x divided by under root 1 plus x squared. So to decide between the signs, if I just go back to the sketch, what I can see here is that my y values for the inverse, function, it's getting decreased. They are getting decreased from this value up till the value which comes on the negative y-axis. Therefore, my sign for the inverse needs to be a negative, and I can see here that f inverse shall be negative 2x divided by under root 1 plus x square. So this is how I will be obtaining the inverse function. So C part of the question says that the function g is defined by gx, which is equals to 2x, and the domain has been given from negative a less than x less than a. A is a constant. State the maximum possible value of a for which the composite function fg can be formed. So we know that the function f was given as negative x over under root 4 minus x squared, and the domain was negative 2 less than x less than 2. So if I need to have the composite function fg, I know that the range of g should be less than the domain of f. So range of g should be less than the domain of f. That means for g of x which equals to x and the domain from negative a till a, my range value shall be, by substituting g of a, it should be negative a less than g of x, which is less than 2a. So this is going to be the range value for the function g here. So I have the range for the function, and for the domain I know that f of x has the domain which is negative 2 less than x which is less than 2. So I know that for range to be within the domain of f, my a value can only be a 1. The maximum value of a should be a 1 for which f of g can be formed. Because if I substitute a as 1 in the range for negative 2a less than gx less than 2a, I'm getting it within the domain which is within the domain of fx, which is negative 2 less than x less than 2. So a equals 1 has to be the maximum possible value here. Now for the last part of the question, it says, assuming that fg can be formed, find and simplify an expression for f of gx. So f of g, we know that the function fx So assuming that fg can be formed, find and simplify an expression for fgx. I have to get the expression for fgx here. So for fgx, I know that g is a 2x, meaning in the function f, I shall be substituting 2x, so that it's a negative 2x here, and this becomes under root 4 minus 2x the whole square. Or I can say that the function value is a negative 2x divided by 4 under root 4 minus 4x square. Or I can say that this is a negative 2x under root 4 into 1 minus x square. Under root 4 is a 2. I can take the 2 common. Under root 4 is a 2. So I can just write it with the 2 and under root 1 minus x square. And so the 2 gets simplified, and I can see now that the composite function f of gx shall be equal to negative x divided by under root 1 minus x squared. So this is how I should be getting the composite function f g x here.